you to kindly look at the comments in this video. In the comments part, I have posted the complete discussion which we are making in a typed form. And also in the comment side, I have posted answers to some questions we discussed in the previous session. In this session, well, we look at what is lier principle. What is lier principle? Lier's principle. If a disturbance is caused to a system in equilibrium, the equilibrium readjusts itself to cancel the effect of disturbance. Well, if your mother is running behind you with a stick because you have done a mischief, what will do? If your mother is chasing you, you try to run away so that she can't catch you. You try to save your skin. Suppose you take a system like nitrogen plus hydrogen gives rise to 2 ammonia plus 92.4 kilojoules energy. This system, nitrogen plus hydrogen and ammonia, they are in equilibrium state. In this reaction, the heat energy term is there on the right side, plus 92.4 kilojoules, indicating that this much heat energy is released. A process where energy released is called as exothermic process. So in this process, which is known as Haber's process to make ammonia, let us see how can I use the lier principle so that I can get maximum possible product. Always you are interested in product. Always you are interested in result. Always you think by putting minimum effort, how can I get a maximum score? Similarly, lier principle tells us by doing what I can get more ammonia. You want to push the equilibrium in favor of ammonia. Very, very important to notice, sir. For a given reaction equilibrium constant value always remain constant as long as temperature is constant. Equilibrium constant value will not change. Equilibrium constant value will not change if I increase the amount of nitrogen or hydrogen or ammonia or whatever. To change the equilibrium constant value, you have only two options, sir, or madam. First option is change the temperature. If you change the temperature, equilibrium constant value changes. Number two, change the style of writing the equilibrium. Instead of writing N2 plus 3H to give ammonia, you reverse it, like 2NH3 gives nitrogen plus hydrogen. Or you change the coefficients. By doing these manipulations, the equilibrium constant value modifies. But here we are not looking at that idea. We are looking at lier principle. Lier principle tells us if I cause a disturbance to a system in equilibrium, or if I cause stress to a system in equilibrium, by modifying the concentration of reactants, nitrogen, hydrogen in this case, or by modifying the concentration of product, ammonia in this case, or by changing the volume of container, or by applying pressure, or by adding unreactive inert gas, I am creating a stress to the system. The system will rearrange itself to cancel the effect of disturbance. Fine. Let us see. If I am increasing the concentration of nitrogen, this is a disturbance to the system. So system will try to cancel the effect, cancel the increase in the concentration of nitrogen. How the increase in concentration of nitrogen is cancelled? Only if more ammonia is formed. Therefore, by increasing the concentration of reactants like nitrogen or hydrogen, I can increase automatically the amount of ammonia produced. So if you want to have more ammonia, keep the concentration of reactants as high as possible. Second, what about ammonia? If I increase the concentration of ammonia, that is the product, backward reaction is pushed. So in fact, ammonia gets decomposed. Therefore, I should never keep the concentration of ammonia more. If I want to have more ammonia, what I do is, the moment ammonia is formed, I will take it out, either by liquefying it or by dissolving it in some water or something. If I start removing ammonia, as I am decreasing the concentration, equilibrium will try to push the formation of more and more ammonia. Therefore, one strategy to get more ammonia is keep the concentration of reactants on the higher side and keep the concentration of product as low as possible. The moment it is formed, you try to remove it. Secondly, effect of pressure. That's very important. You should understand. Effect of pressure. Effect of pressure. You know, only gases experience pressure. Therefore, more number of moles causes more pressure. So if I am increasing the pressure, system will try to minimize the pressure. How the pressure can be lowered? If the number of moles are lowered, the pressure can be lowered. Therefore, whenever I increase the pressure, the equilibrium will push itself in such a side where the pressure is decreased. Pressure is decreased where number of moles are lower. Look here, the left side there are 4 moles, 1 mole of nitrogen, 3 moles of hydrogen. Right side there are 2 moles, only 2 moles of ammonia. If I apply more pressure, equilibrium will go itself in a direction where the pressure will become less. Pressure will become less if the number of moles are less. Therefore, increase in pressure will favor the side where the number of moles of gases are less. Underline gases, only look at gases. Ignore solids, ignore liquids because they don't cause pressure. Therefore, an increase in pressure will favor the formation of ammonia because number of moles are less. Opposite is the effect of volume. Please remember, I am remembering only the effect of pressure, and if I increase the volume, the effect is opposite to that of pressure. That's why I remember. So I don't discuss the effect of volume. Simply you remember the effect of pressure, make it reverse. In this case, if I raise the pressure, forward reaction is favored because in forward reaction side, number of moles are less. If I increase the volume, reverse will happen. Therefore, that way you can work out. Next factor, temperature. If I raise the temperature, reaction will move in a side where there is no temperature. It means endothermic reactions are favored by high temperatures. If I raise the temperature in this equilibrium, right side there is a heat energy term, left side there is no heat energy term. Therefore, a rise in temperature will favor the backward reaction. Hence, you should not put very high temperature. If I put very high temperature, unfortunately, ammonia will decompose. However, under normal conditions, reactions proceed very slowly. To encourage the reaction to happen, you need to supply what is called as energy of activation. Therefore, if you give a little bit higher temperature, say temperature like 500 degrees centigrade or 750 K, the energy of activation is provided to nitrogen and hydrogen, so smoothly reaction happens. Hence, to provide energy of activation, some moderate temperatures are given, but you should never keep very high temperature in this Haber process. Last, exothermic process is always favored by low temperature. Endothermic process is favored by high temperature. Forward is exothermic. Therefore, don't put high temperature. Last, if I add a inert gas if I add, if the number of moles of gaseous products and total number of moles of gaseous reactants are equal, it means delta N gas, change in the number of moles of gaseous substances. If the number of moles of gas are not changing, delta N gas is 0. It means if the total number of moles of products in gases, total number of moles of reactants on the left side, if both are equal, then there is no effect of adding inert gas. If they are not equal in the left side and right side. If delta N gas is not 0, then at a constant pressure situation, addition of inert gas would favor the side where the number of moles are more. So in this equilibrium, if I add inert gas, left side there are more number of moles. Therefore, backward reaction is favorable. Hence, favorable conditions to make ammonia in Haber process are: keep the concentration of reactants high, keep the concentration of product ammonia as less as possible, keep very high pressure as much as 200 atmospheres, and don't keep the temperature very high, working temperature of 750. Also, a catalyst would not change the equilibrium amounts, but a catalyst can set the equilibrium fast. Iron added with molybdenum or KOH as a promoter acts as catalyst. Catalyst always speeds up overall process. It favors the forward reaction. It also favors the backward reaction. It sets the equilibrium fast. It sets the reactions fast. Here we use iron as a catalyst. These are the facts about the Lier principle. Can you apply Lier principle for an important step in contact process? Contact process aims to make sulfuric acid. Second step in contact process is sulfur dioxide gas is added with oxygen gas to get sulfur dioxide. This is also an exothermic reaction. Can you guess what factors favor the formation of SO3 in contact process? Thank you very much. Don't forget, you need to see the comment side, and I wish you all the best. In the tomorrow's session, I propose to post so many questions related to the particular Lier principle and its application. There are many objective questions. Next lecture will be of only very few minutes, but you will have many questions in the comment side. Thank you very much. God bless you. Bye-bye.